Hello everyone. Today we are working on day 4 of our notes packet. Today's standard is standard SID 2, which states I can compare data sets and find the mean, median, and mode. Here's our first example. The first example says, the list below give the number of men and women enrolled in Art 101 across a group of colleges. Use the data listed above to make a double box and whisker plot of the enrollment of men and women in Painting 101. All right, so back to step 1. Okay, we need to make two lists organizing men and women from smallest to biggest. I'm going to start with men first. We begin with a number 3. After the number 3 comes a number 7. After the number 7, it appears that there are two 9s. After a 9 is a 10. After a 10 comes the 12. After 12 is 15. After 15 is 16. After 16 comes 18. And then we have a 22 twice and a 29. All right, for our men, what do we have? Okay, our maximum number is a 29. Our minimum number is a 3. Okay, let's find now the middle number. So we have this, 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 this. Two numbers in the middle. 12 plus 15 is 27. Divided by 2 is 13.5. All right, since 13.5 is our middle number, we're now going to look at the data set like this to find the lower quartile. Here, two numbers in the middle. My lower quartile number is 9. Okay, here, two numbers in the middle. 18 plus 22 is 40. 40 divided by 2 is 20. All right, now let's get the women organized. Starting with the smallest number of women. Our smallest number appears to be 10. After a 10 is an 11. After 11 is 15. Next comes 18. After 18 is a 19. And then we have 21. And we have 22, 1, 2, 3 times. Okay, and next we have a 23. After the 23 is a 30, and we end with the number 31. Okay, our minimum number is 10. Our maximum number is 31. Our median number, we would have this, 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 two numbers in the middle. 21 plus 22 is 43. Divided in half, you have 21.5. 21.5 is the median. Well, if 21.5 is the median, then we're going to have to include this 21 with this data set. So we go here, 15 and 18 makes 33. Divided in half, you've got 16.5. My lower quartile is 16.5. Then here, working our way inwards, here, 22 and 23 is 45. Cut that in half, you have a 22.5. Okay, now you need to have this data handy because now we're going to go on to our first double box and whisker plot. So I'm going to use my data, set it off to the side for myself, and I have got to graph men and women. Okay. My lowest man is at 3, and my highest man is at 29. I'm going to make a dot here and here. My median set of values is 13.5. 13.5 is 10 units from here, but 16 units from here. So I'm going to off-center it just a little bit at 13.5. Okay, then I have a upper quartile of 20. 7 units approximately from here, 9 units from here. I'm going to make it a little closer to here with an upper quartile of 20. And then my lower quartile is 9, and a 9 would be a little closer to 13.5. Okay, I make a line through the center of the data, and I make my box from the lower quartile to the upper quartile. All right, on to our women. So the women start at a little different place, and we kind of need to take this into account, what we did with the guys right here. Our women stop at 31, so I'm going to put my 31 right here. But they start at about 10, so they're in a little bit at about right there. Okay, my median number is 21.5, and I would say there's 20, so maybe 21.5 is just slightly to the right of that, 21.5. And then we need to put in our quartiles. The lower quartile is 16.5, which is almost right in the middle. And the upper quartile is 22.5, which is very close to here. So close, I'm going to put it right above. Okay, we draw our box from quartile to quartile. We draw a line through the center. And that's our double box and whisker graphs, our first double box and whisker graphs. You are now ready to find the interquartile range. The interquartile range is the difference between the upper quartile and the lower quartile. In our case, the interquartile range for men would be 20 minus 9, which is 11. The interquartile range is a very useful measurement. It is useful because it is less influenced by extreme values. It limits the range to the middle 50% of the values. And then it asks, what's the women's interquartile range? So if we took, in this example, 20 minus 9 and came up with 11, then we would go 22.5 minus 16.5. The women's interquartile range is just 6. Here's our second example. We need to practice our double box and whisker plots. Here are the points scored by the Culver Eagles, in their basketball games this year. We have home scores, we have away scores, and it says use the data to make a double box and whisker plot. So home and away. All right, the smallest number for home seems like it's 49 points. Mark it out, it's been used. After 49, we go on to 69. After 69 is a 78. After 78 is 80. After 80 is 81. After 81 is 82. After 82 is 86. After 86 is 87. After 87 is 90. After 90 is a 93. And we end with a 94. So what do we know right now? Okay, we know that our max number is 94. And our minimum value number is a 49. Okay, and at this time we can go ahead and calculate our middle number. So here, 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 we got an exact middle number of 82. Okay, well, if this is an exact middle number, we now focus on this, and the median of our lower quartile is 78. And looking here, this median happens to be 90. Okay, so we need this information here, and we go on to the away games. The away games, lowest score scored ever was a 57. Mark it out, it's been used. After a 57 comes a 58. Mark it out, it's been used. After 58 is 59. After 59 is 64. After 64 is 65. After 65 is 67. After 67 is 68. After 68 is 69. After 69 is 71. After 71 is 72. And after 72 is 84. Okay, what do we know? We know that the minimum number is 57 and that my maximum number is 84. Okay, at this time we need to find the middle number. $67. Okay, discarding that middle number and looking for the next middle number, we have a 59 for the lower quartile and a 71 for the upper quartile. Okay, we're going to need this data to make our double box and whisker plot on the next page. All right, so we're going to go ahead and graph starting with home. Okay, for home, our lowest value was a 49 and our highest value was a 94. Okay, right in the center is an 82, but 82 is really not close to 49. It's very close to 94, so I'm going to put my median kind of squeezed over here at an 82. And then my lower quartile is a 78, so pretty close to 82. And my upper quartile is a 90, so a little bit shifted this way. I make a box from quartile to quartile, and I put a line right through my center, which is my median. And then I go on to the second graph. Okay, my lowest value is a 57 when I'm playing in a home game. Sorry, an away game, 57. Okay, and my maximum value is an 84, so not quite as big of a range. Then my middle value is 67, so 67 would probably be closer to 57, maybe about right there. Okay, and then I have my upper quartile being at 71 and my lower quartile being at 59. I make a box from quartile to quartile and I put a line right through my median. Oh, I had some questions to ask. All right, answer, sorry. Which data set has the greater median? So looking at our medians, which one has the greater median? The home games. About how much greater is the median of the data set? Well, this median is at an 82, and this median is at a 67, so it's about 15 greater. What is the range for the home and the range for the away? Okay, the range is 94 minus 49. Which is 45. That's home. Okay, and for the away games, 84 minus 57 is 27. All right, moving on. Calculate the interquartile range for the home and away games. So going back to this, the interquartile range, remember, is just your quartiles. So my IQR for home is 90 minus 78, which is 12. And my IQR for away is 71 minus 59, which also happens to be 12. All right. Now, thankfully, we have some made for us. The box and whiskers plot shows the lifespan in days of two different types of batteries. Which data set has a greater median? And about how much greater is that median for the data set? Okay, which data set has a greater median? Duracell. About how much greater is their median? This is at 20 and this is at 14, so it's about 6 more. The double box and whisker plot shows the average scores from basketball games from Trevor Brown, who is on top, and Alhambra, who is on the bottom. What is the range for each team? So Trevor is at 29 and 3. Their range is 26. Alhambra is at 31 and 10. Their range is 21. Which of the following is true about these data sets? All right, so for these, I'm actually going to pull out a calculator, and I suggest you pull out a calculator or pull out a phone, something that you can do some math on. All right, we've got to find, it's asking for the medians, the ranges, the means, and the variances. Okay, the word variances, that's a distractor. We're not going to choose that at all right now. Here we go. So let's find our median. Okay, and this slide is actually very nice to you because they already arranged it. So we have two sets. We have the median up there and we have the median down here. All right, so my first one has a median of 30. My second one has a median of 32. Saying that the medians are equal is not it. All right, the next thing it asks is the means. Are the means equal? Okay, and a quick review of mean, it's you add all of them up and divide by how many there are. Okay, so this is where my calculator is really going to come into play. Okay, so 24 plus 25 plus 28 plus 30 plus 31 plus 33 plus 37. 208. 208 divided by what? 1, 2, 3, 4, 5, 6, 7. Divided by 7. Okay, this one is saying that my mean is 29.71. Okay, going on. Apologize, my lights went out for just a moment. Here we go. All right, adding up 17, 27, 29, 32, 32, 34, and 37. We have 208, which again, we have the same amount of numbers, so when we divide by 7, we're getting 29.71. All right, so these are equal. So definitely it's C. Now, our district loves to throw things at you that are a select all that apply, so we're not going to stop yet. Okay, we're going to look at the ranges. A range is easy. You take the biggest number and subtract the smallest number. So for this, 37 minus 24 would be 13, and 37 minus 17 is 10. So we have one answer. The answer is C. Those are not equal. Which of the following is true about these data sets? Okay, the medians are equal. Let me check very quickly and make sure that these aren't the exact same slides, because if they are, we already have a lot of our answers. Nope, they started at a different number. All right, here we go. The medians are equal. Well, they arranged them for you, and already you can say that these are not equal. Okay, then we go on. The means are equal. Okay, we have to figure that out. So let's go ahead and just start answering this again. So 24, 25, 28, 30, 31, 33, and 37. 1, 2, 3, 4, 5, 6, 7. Divided by 7. Okay, I know that my mean on the top value is 29.71. Okay. Then, going on, my mean for my second set of data, 24 plus 27 plus 29 plus 32 plus 32 plus 34 plus 37 divided by 7. This one is coming to 30.71. My means are not equal. I already told you this one right here is a distractor. Just mark it out, which means my ranges better be equal. Okay, so let's just check the range. All right, 37 minus 24, 13. 37 minus 24, 13. The ranges are indeed equal. All right, the last example we have, which of the following is true about these data sets? Okay, mark this out. The medians are equal. Guess what? They are. But in case it's a select all that apply, I'm going to go ahead and just start doing my work one last time. Okay, 24 plus 25 plus 28 plus 32 plus 33, 34, and 38, divided by 7. My mean for the first set of data is 30.57. For the second set, 17 plus 27 plus 29 plus 32 plus 32 plus 34 plus 37, and dividing that by 7 numbers, I have a mean of 29.71. Okay, so it's not that. Ranges, 38 minus 24 is 14. 37 minus 17 is 20, so it's not the ranges. All right, at this time, we have just finished up the day 4 notes. You need to go to your homework packet and at this time complete the day 4 homework. We'll see you again tomorrow.